Dear learners, welcome you all to this channel, and in this video we are going to see the certain basic concepts of numbers. So let's get into this video to know more about the concepts. So this video is going to carry concepts based out of coprimes, fractions, odd and even numbers. So let us understand the basics of coprimes, fractions, odd and even numbers in this video. Before actually getting into the concepts of coprimes, I believe that it is very important to understand the concepts of prime numbers. So as you all know, prime numbers are nothing else but just the natural numbers that are divisible by 1 and the number itself. Okay, so this is very important. So it has only two factors which are just the number and the 1 and the number itself. So in other words, if I have to explain the proper definition of prime numbers are, they are positive integers of course, and they are greater than 1 with exactly two factors as I mentioned in the previous statement. And what are those two factors? They are nothing else but the number 1 and the number itself. So for example, if we are going to take certain numbers, see in the other half of the slide that I had mentioned the examples of prime numbers, and the examples of prime numbers are 2, 3, 5, 7, 11, 13, etc. So you can still take account of 17, and then you have 19, then you have 23, and then you have 29, and so on. Okay, so how to find if a given number is a prime number or not, so that again I have given in a separate video, so you can go through that in order to understand either to find the factors of any given number or to find the given number is a prime number or not. So for as of now in this video, so let us just restrict ourselves to know the prime numbers and the definition of prime numbers, and we'll move on to the coprimes, concept of coprimes. And see, you also have another important fact here. 2 is the only prime number which is even. So no other prime number are even numbers. So the only even prime number is 2, and all the other prime numbers, if you could notice, it will always be your odd numbers, because once it is divisible by 2, of course you'll have 2 as a factor, additional factor. So as per the definition, a prime number has to have only 1 and the number itself, and that is why the only even prime number is 2, and all the other numbers are, all the other prime numbers will be your odd numbers. Okay, so let's move to the concept of coprimes. So co-primes again are nothing else but a set of two or more numbers. Okay, two or more numbers that have no common factor other than 1. So this is very, very important. So co-primes are a set of, let's say for example, I'll give you a set of numbers. Let us say that I give you, see here again we have quoted an example. So you have an example as 5, 7 and 9. So this is a set of numbers, a set of 3 numbers. So a set of 3 numbers where you have no common factor other than 1. So let's try to work this out. So I'm going to take 5. So the factors of 5 are 1 and 5. And let's take 7. The factors of 7 are 1 and 7, because 5 and 7 are prime numbers. So 9, I'm going to take 9 for an example. So the factors of 9 are 1, 3 and 9. So 9 is not a prime number. You also have another factor called 3. It's a square number as well. So the factors of 9 are 1, 3 and 9. So let us take the factors of 5, 7 and 9. So the common factor or the greatest common factor or the highest common factor in whatever you call is just 1, and no other number are the common factors. So I would say that 5, 7 and 9 are co-primes to each other. See, remember, for a set of numbers or for any number to be co-prime with another number, it is not mandatory that it has to be a prime number. Okay, let's take another example. See, I'm going to take 16 and 25. Okay, 16 and 25. And I believe you all know that both 16 and 25 are not prime numbers, because if you take the factors of 16, you can say that you have 1 and then 16, then you have comma 2, and then you have 8, and what else, you still have 4 as factors. Okay, so 1, 2, 4, 8, 16 are factors of 16, and 25, if you could take the factors of 25 are 1, 25, and then you have 5 as another factor, isn't it? So the common factors, despite having so many factors, Like 16 has 1, 2, 3, 4, 5 and 25 has 3 factors. Still the common factor is only 1. That is the highest common factor or the greatest common factor is just 1. Okay, so that is why I tend to say that 16 and 25 are co-primes to each other. So always remember, for a set of numbers to be co-primes, it is not necessary that they have to be prime numbers. Even non-prime or composite numbers, non-prime or composite numbers can also be co-prime to each other, provided their greatest common factor is only 1. Okay, so here are some examples that I have given, so you can just go through that. See if you could again take this example, 81 and 16, both are not prime numbers but still they are co-primes to each other. 216 and 215, they are not co-primes to each other but still they are, they are not prime numbers but still they are co-primes to each other. Got it? So there are some rules where you can always remember when it comes to co-primes. Two consecutive numbers are always co-primes. Okay, so if you can take 8 and 9, okay, 9 and 10, and then let's say 12 and 13, or let's say 14 and 15. See, the examples that I'm quoting are such that they are composite numbers. Got it? So two consecutive numbers are always co-primes to each other. And the second rule is that two consecutive odd numbers are again co-primes to each other. So that is how I said 5, 7 and 9. Got it? So they are consecutive odd numbers. Got it? So remember, it's not in all the cases 3 you can take, but in every cases you can definitely, I mean, for a rule to be implied, it has to be same throughout. So that is why I tend to say the two consecutive odd numbers are always co-prime to each other. And two prime numbers are also co-primes to each other. Okay, two prime numbers are also co-primes to each other. Let's take 13 and 17, they are co-primes to each other. 17 and 19, they are co-primes to each other. So it falls under two different categories. 17 and 19, if you could take, they are two consecutive odd numbers as well, and also two prime numbers as well. Got it? And two composite numbers can also be co-prime. So that's what I have been mentioning. Like two composite numbers can also be co-primes. Okay. So just got to, I mean, listen to this again. You can rewind for some time and then, listen to this particular statement again for better understanding. So let's move to the next slide, which is the just basics of your fractions. Okay, so here is that I have given some examples. We have touched all the examples except 84 and 65. So I expect you to tell me if 84 and 65 are co-primes to each other in the comment below. Okay? Then, so this slide is all about your fraction. So fraction is something which we have been dealing with since the childhood, isn't it? A fraction is a part of a whole where, and it consists of two parts where a numerator and denominator. So the numerator is a number on the upper part. Okay, so I'm going to take this example. So let us take 1 by 5. Okay, so this is a fraction. Got it? And the number above the line. Okay, so this is the line and the number above the line. This is called as your numerator. Right? This is your numerator. And the number below the line or below the bar is called as the denominator. So this is your denominator. Okay, so when we take this as an example, so if you are going to take 3 by 4 as an example, 3 is your numerator and 4 is your denominator. So these are the examples of fractions. So fractions are of different types. There are a lot of categorization of fractions which we are going to see in the next slide. So the types of fractions are that, see, you have something called as unit fractions. So what is meant by unit fractions? Fractions with numerator 1 is called as unit fraction. So whenever you have 1 in your numerator, so we tend to call them as unit fractions. So example is 1 by 7. You can still say 1 by 5, 1 by 31, 1 by 100, 1 by 200. All that are unit fractions. Okay, so now what is meant by proper fractions? Yes, proper fractions are something where the numerator is always less than your denominator. So what is the numerator? The number above the bar is your numerator. So the numerator, whenever the numerator is less than your denominator, we call that as proper fraction. So still we can say that let's say 200 by 333. So this is again a proper fraction. So I'm taking bigger values, for example 200 by 33. So 200 is always less than 333. So this is a proper fraction. And on the contrary, an improper fraction is something where the numerator is more than the denominator. I don't say equal because when it is equal, it becomes 1. So when the numerator is greater than the denominator, then we call it as improper fraction. So 5 is greater than 3, is a bigger number than 3. So it is an improper fraction. And what is mixed fraction? A mixed fraction consists of a whole number along with a proper fraction. So along with a fraction where the numerator is less than the denominator. Okay, there will always be conversions between these two. So that you have to remember. There will always be conversions between mixed fraction and improper fractions. Okay, let us take for example, see, I'm going to convert this mixed fraction, that is 8/2 by 3, to an improper fraction. So how do I convert? I'll multiply these two. Okay, so this is my whole part. My whole part here is 8 and the proper fractional part is 2 by 3. Okay, so now that I'm going to multiply 3 and 8. So 3 8 is 24 and now I'll add this value, that is my numerator, with this product. Okay, so 24 plus 2 becomes 26. So this is going to be 26. My numerator will become 26 and my denominator is just the same as my proper fraction. So the proper fraction has 3 as my denominator and here also it's going to be 3. So let me just take another example. So you have another example which is 5 by 3. That is an example of an improper fraction. So let us take that. Okay, so 5 by 3 or let me just take another example of mixed fraction, that's better, and then we'll move for a improper fraction. So the mixed fraction example is, I'm going to take 11 3 by 5. So let's put it over here. So 11 3 by 5 is going to be your next example. So 11 3 by 5. Okay. So if you have to convert, I'll again multiply the whole part with the denominator. So 11 into 5 becomes 55. 55 plus 3 is 58. So my answer is 58 divided by 5. Okay. So this is my conversion between mixed fraction and improper fraction. And also the same vice versa, like improper fraction can be converted into mixed fraction. Let us take this example now. So 5 by 3, right? So let me just divide 5 by 3. I'll do it here. So 5 divided by 3. So when we are going to divide 5 by 3, it's just 1. Then I have 3 and my remainder is 2. So I will take the quotient as my whole part. The quotient is this, and then my remainder as the numerator divided by the denominator is just as in the denominator of the improper fraction. So 1 2 by 3, which means you have one whole part and you still have 2 as your remainder divided by 3. Okay. So if you are going to convert improper into mixed, you can just cross check. 1 into 3 becomes 3. 3 plus 2 is 5. 5 by 3. So wherein you get your improper fraction as such. Okay. So this is how you convert between improper fraction and mixed fraction. So for example, let's again convert 26 by 3. So we know 26 by 3 is nothing else but 8/2 by 3. So if you are going to divide, you have 26 divided by 3. I'll take the, I have 8 3's in this, which is 24, and I still have 2 as my remainder. So I'll take this, can be written as 8, and then the remainder is 2 divided by 3. So 8/2 by 3, where you get the same answer indeed. Okay, so that's how you can convert improper fraction and mixed fractions. Now let's move on to the like fractions. So like fractions are fractions with the same denominators. The same denominators are called as like fractions, and just the opposite of that is your unlike fractions. So what is unlike fractions? Of course, with different denominators. So if the denominators are same, we call it as like fractions, and if it is different denominators, we call it as unlike fractions. And what is meant by equivalent fractions? So equivalent fractions have the same value after being simplified or reduced. Okay, for example, see 6 by 4 and 12 by 8. I call them as equivalent fractions just because I multiply 6 into 2 to get 12. And same number I multiply with my denominator in order to get 8. So I'm going to multiply the same number with the numerator and denominator to get the next highest number. So I call the original fraction and the new fraction as equivalent fractions. Or in other words, You can also say, see, if I get 12 by 8, okay, 12 by 8, if I'm going to simplify this, so 2, I'll get 6 and this will be 4. So 6 by 4 is another equivalent fraction. So what is another equivalent fraction for 6 by 4? I still simplify and this becomes 3 by 2. So I would say that 3 by 2 is another equivalent fraction. So 3 by 2 is another equivalent fraction for 6 by 4 and 12 by 8 as well. Or in other words, I can say that you see, like 3 by 2 and 6 by 4 and 12 by 8 are all the equivalent fractions. So when you simplify or reduce, you should get the you should get the other fractions. So then you can call them as equivalent fractions. Okay, so now let's move on to comparing fractions. So comparing fractions is always done. See, this is the only method which is applicable for every fraction type. Okay, so whatever fraction type that you take, you can just compare using your cross multiplication technique. For example, if I'm going to compare 1 by 2 and 3 by 4, and I need to understand which is the greater fraction. Okay, so it's a clear picturization where I multiply 4 with 1 and I multiply 2 with 3. So multiplying 4 and 1 becomes 4, multiplying 3 by 2 becomes 6. So 6 and 4 I'll compare. So since this is a bigger number, I would say this fraction is your bigger fraction. Okay, so it's very simple. You can cross multiply and then compare and then decide which is the greater fraction in that case. Now let's again take another example. So 1 by 3 and 1 by 10. I am again just going to, compare. This is very, very simple. I just take 3 to the side and I take 10 to the side. So this will be my 10 and this will be my 3. So which number is greater? This is greater. So I would say 1 by 3 is a larger fraction in this. Okay, even if it is the same denominator, it is just the same concept, but you see, like 3 by 8, 3 by 8 and 5 by 8. So these are the two numbers that you have. Despite you just multiply this, so it's going to be 3 into 8 and 5 into 8. So anyways, when comparing 8 and 8 goes off. So which is the greater number, 3 or 5? 5 is the greater number. So I would say 5 by 8 is a greater number. Or on simplification process, you can still say that when you have the same denominator, you can just compare the numerator alone. So whichever numerator is bigger, so that fraction is bigger. Simple. For example, if I'm going to take say 1 by 3 and 1 by 3 and 2 by 3. So blindfoldedly, I can say that 2 by 3 is my bigger fraction because it is the same denominator. 3 and 3 are the same denominator. I need not do any other calculation. I can just compare 1 and 2 and say whichever is greater. Or let's take another example. So if we are going to take another example, let's say 168 divided by 224 and 183 by 224. So you need not multiply since it is the same denominator. So forget about the denominator. You compare only 183 and 168. So 183 is a bigger number. 183 by 224 is your bigger fraction. Simple. Right? So this technique also you can apply if it is the same denominator. So let us just take some examples. Let me say let me take 16 by 23 and let's say 21 by 23. Okay, so again it is the same denominator. So I can just compare 16 and 21. I would say 21 is a bigger number. So this fraction is a bigger fraction. So if it is a different denominator, so let's try for different denominators. So let's take 62 and let us take 1 or 31, or let's take 31. You can still take 30 so that it will be easy, and here it's going to be let's say this is 4 and let's say this is 5. So point number 1, you can still simplify. So 4 by 62 I can still simplify. So this becomes 2 by 31 and this becomes 1 by 6. Okay, 1 by 6. So fraction that I need to compare is 2 by 31 and 1 by 6. So now can you tell me the answer? Sorry, 31 and 1 by 6. Okay, so now can you tell me which is greater? Of course, yes. So when you cross multiply, this becomes 12 and this becomes 31. So since this is greater, I would say 1 by 6 is a greater fraction. or a bigger fraction. Got it? And now moving over to odd numbers and even numbers, it is very, very simple, which we have been dealing with odd numbers and even numbers since childhood. So just for your example, I've given that an even number is a whole number that can be divided by 2 without a remainder. So whenever you divide by 2, you don't get a remainder. You would, confirm that that is a even number. So here are some examples that I've given. And same way, odd number, when you divide by 2, you always leave it always leave a remainder of 1. Okay, so that tends to be your odd numbers. So odd numbers are also given here. That is from 1 to 100. All the odd numbers are mentioned in the other part. So you have some rules for odd and even numbers. So always remember, odd even number plus even number will give you even number. Even number plus odd number gives you odd number. Odd and odd gives you even number. Even into odd gives you even number. Even into even gives you even number. Odd into odd gives you odd number. Even number power x is always even. Odd number power x is always odd. X being any value despite. Okay, so see, another easiest technique to remember. Okay, you need not remember these rules always, but a very easiest technique is that let us just take examples. So for even number, I'm going to take 2 as an example, and for odd number, I take 3 as an example. So 2 into 2 plus 2 is 4, which is again a even number. So that's how I say even plus even is even. Okay, even plus odd. So 2 plus 3 is 5, which is a odd number. So even plus odd is a odd number. Odd plus odd. So 3 plus 3 is 6, which is an even number. So that's how I say odd plus odd is even number. Even into odd. So 2 into 3 is again 6, which is your even number. And then 2 into 2 is 4, which is your even number. So in all the cases, you can just take the even numbers example as 2 and the odd number example as 3 and remember. Okay, even number power x. You see 2 power anything. Okay, 2 power anything gives you even number. 2 power anything gives you even number. And same way 3 power anything gives you odd number. So that's how I end up saying odd number to the power x is always odd and even number to the power x is always even. Okay, I hope this is clear. So we have seen concept based out of odd and even numbers, fractions, co-primes and also prime numbers. So you can post your doubts if any in the comments below, and also I had just asked a question in the initial few slides, so you can post the answers of that question as well. Thank you so much for watching. Stay connected.